Hey guys, we're gonna try something a little bit different since I'm not there. We're starting a unit on probability, and this is the first lesson, so we're gonna kind of make it a digital lesson for you. I'm gonna go through this first page of the worksheet that you should have received, and I'll go through the front side, and then you will do the back side using this video and the examples that we go through. So just starting at the top, talking about probability, it's a measure of the chance that a particular event will occur. So in the warm-up, you did, you compared, I think, bending your thumb and rolling your tongue. So you just compare those probabilities to each other and what's the probability that you could do both or you could do one or the other. Here we're going to look at some other examples where it might not be quite as clear-cut. So the next two lessons focus on tools for listing all of the possible outcomes of a probability situation, and that's called a sample space. Generally, when you have previously determined probabilities in situations in which each outcome you listed had an equal probability of occurring. But what if the game is biased, meaning that not each one has the same probability? That's what we're going to look at here. So for these, we want to use an area model. And so the area model usually involves this box that you see over to the right-hand side. We're going to make kind of different spaces inside so it gives a more visual look to it. An area model uses a large square with an area of 1. So if you change 1 into a percentage, then it's actually 100%. So that's kind of what that represents. So let's just say, for example, that the probability that a student in the class can bend their thumb is 67%. So up here we can put 67, and so we can write that, if we want to write it as a fraction, 67 out of 100. And so that means that if 67% can bend their thumb, then, well, what's 100 minus 67? 33. That means 33% cannot bend their thumb. So if we write that as a fraction, we've got 33 over 100, and that'll be important in a couple minutes. And then let's just say that the probability that a student can roll their tongue is 43%. So 43, and we can again write that as a fraction, 43 over 100. So that means that's the probability that a student cannot roll their tongue. 100 minus 43 would give us 57%. So 57 as a fraction, 57 over 100. Okay, so we want to kind of represent that over here in this box. And so what we do is we divide this out based on our percentages. So over here in the roll tongue area, we have either yes or no. There's no other options besides yes or no. And so the percentage of students that could roll their tongue was 43. So we kind of divide this out, like here's 0%, here's 100% up here. So 43 would kind of fall, if this is the middle right here, then 43 would probably fall just below that, right along there. So then everything below that line would represent students that can roll their tongue. So we would write that over here on the left-hand side, that's yes. So those are the students that can roll their tongue, and that would be 43 out of 100. And then up here on the top, that means this remaining space above the line would be no. Let's try that again. No. And so that would be the 57%. So 57 out of 100. Same idea along the top. You're going to kind of divide it out. So over on the left, we'll say that's 0%. And then over here on the right, we'll say that's 100%. So for can bend their thumb, that's 67%. So again, if this is the middle, probably want to go a little beyond that. 67% is about 2/3 of the whole 100%. So maybe right in there. So, and we want to label it as well. So yes, I've got 67 out of 100. And then this one's no. And that would be 33 out of 100. So now to figure out all of the stuff that goes on the inside, we always want to take the fractions and multiply them by each other. So to figure out the probability in this box, we want to take these two fractions and multiply them by each other. And multiplying fractions is easy. You just multiply the tops of the fractions, the numerators, and you multiply the bottoms, or the denominators of the fractions. So in this box up here, we would take 57 times 67, which if you plug that into your calculator, it gives you 3,819 over 100 times 100 gives us 10,000. Okay, it's always nicer to work with decimals. So I'm going to take that and I'm going to plug it into my calculator. And when I do that, I get a decimal, so 0.3819. So that's probably what I'm going to use for this box. So that means that 38% of the students in the class can bend their thumb, but not roll their tongue. So same idea in the other boxes. For this one, I'm going to take the 33 times the 57, which gives me 1,881, sorry, it's a little messy, over, again, 10,000. And when I plug that into my calculator, I get 0.1881. Okay, and that's the percentage or the decimal that I want to keep in mind. And to change it to a percent is easy. You're just going to move your decimal point 2 places to the right, and that gives you the percent. So then down here, I'm going to take these two fractions and multiply them by each other. So 43 times 67 gives me 2,881. And then 100 times 100 is 10,000. And when I plug that into my calculator, I should get a decimal again, so 0.2881. And then this last box over here, you're going to multiply your fractions again one last time. 43 times 33 gives me 1,419, and then over 10,000 on the bottom. Plug that into your calculator, 0.1419. Okay, so I've got all of my probabilities. Now I can answer any question that it's asking me. So I think, let's see, what's the question down here? We've determined the probabilities of the 4 possible outcomes, which is part B. Now part C asks, what is the probability that a randomly selected person can roll his or her tongue but cannot bend his or her thumb back? So we want to look for those two pieces up here. So can roll his or her tongue, that would be this one right here. So we want to look in that row. And then cannot bend his or her thumb back. So that would be in this row here. So they would come together in this box. So that would be the probability, the answer to that question. 0.1419. If you like a percentage, move your decimal place or decimal point 2 places to the right. So 14.19%. Okay, so moving down to the second one, this is slightly different than just a yes or no question, but it's still the same kind of idea. I'm going to move out just a little bit here. So then the problem is you and your friend may not only look different, but you may also have different types of blood. For instance, members of the American Navajo population can be classified into 2 groups. 73%, which is 73 out of 100 of the Navajo population, has type O blood. So we want to make sure that we keep those together, 73 and type O, while 27% has type A blood. Suppose you select 2 Navajo individuals at random. What is the probability that both individuals have type A blood? So we'll answer that question in the end. What we first need to do is complete an area model and determine all of the probabilities inside. So to do this, we want to make a box, and I want to leave a little room on the left and the right hand side. I'm sorry, the left and the the left-hand side and the top, because that's where I'm going to be writing out my options and my probabilities that I'm eventually going to have to multiply in. So you want to make kind of a big square, and then we want to start listing out our possibilities. So we're talking about two different individuals, and that's what's going to go on the left-hand side and the top. So then over here, I'm going to write individual number 1, and then up here I'm going to have individual number 2. And I'm going to put my options on the left and the top. So the options are actually the same for both individual number 1 and number 2. It's type O blood and type A blood. And the percentages are the same as well, because the probabilities are the same no matter which person you are. So for individual number 1, it's going to be for type A blood. If we go back up and kind of look at which percentages go with which, for type A blood, it's going to be 27%. Has that, and O would be 73%. So then I'm going to start with the 73%. If this was about halfway, then I would say 73. That's about 3/4 of the way up. So probably right here. So then this bottom part would be type O, and that's 73 out of 100. That means that A is going to be up here, and that's going to be 27 out of 100. It's going to be the same thing along the top. So then type O, again, 73%. So if, let's see, the left-hand side, if that's 0, and this is 100% over here, 73% is going to be, again, about 3/4 of the way. So about right there. So we've got type O, and that's 73 out of 100. And then A, 27 out of 100. So to figure out the probabilities on the inside, it's going to be the same kind of thing. Multiply your fractions. This one where we have A and O meeting right here, you're going to multiply 27 times 73. We're going to get 1,971 over 100 times 100 is 10,000. So when we plug that into our calculator and get a decimal, we get 0.1971. So then same idea in these other places. 27 times 27 over here where A and A intersect would be 729 over 100 times 100 is 10,000. So when we make that a decimal, it ends up being 0.0729. So I'll put a box around these because we are going to need these. Where O intersects with O down here, we would have 73 times 73, which gives us 5,329 over 100 times 100 is 10,000. So when we plug that in to our calculator, we get a decimal of 0.5329, meaning 53.29% would have O and O. And then over here, we've got 27 times 73 in our last box, so 1,971, 2, 3, out of 10,000. So that decimal would be 0.1971. So now we've got all of our probabilities and we are all set to answer the question. So the question is in part B, it repeats the question, what is the probability that two Navajo individuals, which are two on the left and the top, selected at random, have the same blood type? So these probabilities in here are dependent on which one has which blood type, what's the probability of one occurring and the other occurring. So we are looking specifically at two Navajo individuals having the same blood type. There's a couple different possibilities for this. One possibility could be that they both have A, which would be, let's get this on here, this one right here. The other possibility is that they could both have O, which would be this one right here. So now it's not just one box, but it's two boxes. And that's pretty easy to handle. We just want to combine those two, so 0.0729 plus 0.5329. And we take that and we can plug it into our calculator, and it should give us a decimal of 0.6058. If you like a percentage, 60.58%. Either way will work, decimal or percentage. So that's how we handle these. This is an area probability model, the box with all the percentages or probabilities on the inside. Figuring out what's on the inside is easy. Just multiply the two fractions where they would intersect, and that gives you the probability inside. Once you've got all of your probabilities, you're all set to go ahead and answer the questions that are presented to you. So just to kind of get you started on number 3 here, it's the same kind of idea as number 2, except there are more blood types possible. So on your left side and your top side, when you're trying to figure out, well, what things go there, the left side and the top side are going to be your 2 different individuals. So one's going to be Joe and the other one's going to be Nick, those poor Jonas brothers. And then you're going to have more than 2 blood types this time. You're going to have 4 blood types, O, A, B, and AB along the left side. And then the same thing across the top, O, A, B, AB. So you're going to have a lot of multiplying into the box to do. So good luck. I will see you on Monday.